So today we're learning about Huffman Trees prefix code, and you'll be given a list of numbers, which is your frequency. And by getting your frequency, you add all the top numbers. So A appears 17 times out of 63, and B appears 10 out of 63, and so on. So your first step is to list the largest number to the lowest number. 30, 17, 10, 5, and E is 1. And what you're supposed to do is you add the bottom two numbers. You always start at the bottom, and 5 plus 1 is 6. And then you move on to your next number. And 10 plus 6 is 16. And by every time you add something, it's another step. So this is another step, and it's still at 30, and this another step, it's still at 17. And now you add the next set of numbers, which is 33. And 33, and your 30 is still at 30. But because 33 is larger than 30, you switch places. So your 33 is up here, your 30 is here. And now you want to list, or you want to name each letter with bits. And you start with 0, 0, 0, 0. Because the first line requires 1 bit, and the 33, the first two numbers are 1 bit. And now you have 17 and 16, which requires 2 bits in naming them. So whatever this number was, which is 1, you add an extra bit at the back. And this is a 1 because you want these two to be different. And now for this one, for 10 and 6, it starts with 1, 1, and it ends with a 0. 1, 1, and it ends with a 1. So you're basically changing the last bit that you added on. And the last two numbers, it's 1, 1, 1, and a 0, and 1, 1, 1, and a 1. Yeah. And now your prefix code for C is 0, A is 10, B is 110, D is 110, and E is 1111. And we can do another example. So our second example is going to be this. And like before, we start with the biggest number, which is E at 37. Then G at 19. B at 13. D at 8. F at 5. A at 4, and C at 2. So now you add the bottom numbers, which makes 6. But 6 is greater than 5, so now you want to switch places. 8 remains in 8, 13 remains 13, and 19 remains in 19, and 37 is So now you switch spots. Now 6 is here, and 5 is here. Now you can add them. Now 11 is greater than 8. 13 is still 13, 19 is still 19, 37 is still 37. And 11, switch spots. 11's here and 8's down here. Now you can add these together, which makes 19. And 19 is greater than 13. So you switch spots. You add them together, which gives you 32. And 32 is greater than 19. So you switch spots again. 19 is 32. You add them together and you get 51. And now that 51 is greater than 37, so you just switch them. 51 and 37. And you don't add the last or like top number with the other one. So now you have to name them again. This 37 will be 0, 0, 0, 0, 0, 0, and 0. Because these two numbers are always named with 1 bit. So 51 will be 1. And now, like I said before, you start with 1 and 1, and you add an extra bit because these two have to be 2 bits. So this is 1 and 0, this is 1 and 1, because you want to make them different. This is 1 and 0. 19 will be 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. And now whatever you added these two, it'll be 1, 0. It'll start with 1, 0, like this one. But you're adding an extra bit because it has to be 3 bits. So 19 is 100 as well. 13 is 101. And now with these, it's 4 bits. 11 is 0, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1. And now these numbers will start with 1,000 with another bit. And now the last two numbers are 1, 0, 0, 0, 0, and a 0. 1, 0, 0, 0, 0, and a 1. So your prefix code for E would be 0, G 11, B is 101, D 1001, F is 10001, A is 10000, and C 10001. And you notice that the letters that are less used have like bigger numbers because it would make it easier to write. Because E shows up so many more times than the rest of them, and you only have to write 0 once.